All right, section 410, balancing redox reactions. And we're going to do this by the oxidation number method. Here are your steps. I'm not going to read them aloud. And here's our first problem. Step 1, assign oxidation numbers to all atoms in the equation. Now really you only need to figure out oxidation numbers. It's okay, you can come in. For the atoms that change, and just looking we can see that tin is going to change. And typically it's your metals or your halogens. So I just happen to know it's the chromiums that are going to change. So you can calculate those. Pause. I'm going to delete this box so you can see it in a second. Okay. Tin went from 2 to 4, and chromium went from 6 down to 3. And note there's one chromium here and 2 here, so we're going to need a 2 in front of this. So step 3, we're going to see this changing. Oxidation changes by 2, reduction changes by 3, but there's 2 of them, so it changes by 6. Students are walking into the room. So we need to put a 2 in front of here because to balance the chromiums, and then to balance the total reduction with the oxidation, we have to put the 3's in front of the tins. So now we have a 6 with a 6. And step 5, balance the rest by inspection. You can pause this, or I'm going to show you in a moment, but we're just putting the numbers in front of the hydrogen and the water. And here you go. There's your overall balance reaction. Next one. Okay, you can try this on your own, go through these different steps, but I'll lead you through the steps. So step 1, we have to look at the oxidation numbers, figure out how they changed, and you should see that the silver clearly changed, and the nitrogen will be the other one that changed. But you can get your practice doing all the oxidation numbers. So there's steps 1 and 2. Silver goes up by 1. Nitrogen, here it's 5, here it is 2, so it went down by 3. And then the next step, oxidation changed by 1, reduction changed by 3. The atoms are the same, so we don't have to worry about balancing the atoms. But we do have to balance the electrons now. So if oxidation 1, reduction is 3, we need to put a 3 in front of the things that got oxidized to balance our electrons. So we'll put a 3 here, and a 1 here, and here. And we balance the rest by inspection. So you should do that now. I'm going to show it. You can pause. There's your balanced equation. All right, last example. Note that the chromiums, there's 1 here and 2 here, so we're going to need a 2 in front of there. The irons, step 1, let's look at our changes. Iron goes from 2 to 3. Chromium, you should pause and calculate these. Chromium goes from 6 to 3. So, chromium goes down by 3. Iron goes up by 1, and we need to balance this overall, but note that we had 2 chromiums, so actually, even though each chromium goes down by 3, there's really a change of 6 total here. So the irons will need to put a 6 in front of there. Okay, so we'll need 6's in the front of the irons, and a 2 in front of this chromium. It's okay. People are still walking in the classroom. A 2 in front of this chromium. And the reason why we need the 6's here is because each chromium changes by 3, but I have 2 of them, so the total there is 6. So I need a total of 6 here. There was only 1. 1 times 6 is 6. And we balance the rest by inspection. So you should be able to pause and do that, and here are your answers. Okay. Now you're going to do these on your own. You should pause this. The answers are about to show up. But you should pause before you look at the answers. I'm not going to go through these. Just want you to have some practice. And here are your answers. You should have paused and filled these in already on your own. But here are your answers.